Welcome to Lecture 13, Unit 3, and this is the addition rule for probability. My name is Jorge and this is for Statistics 2023. And so in this lecture, what we're going to be talking about is we're going to find the probability of compound events using addition rules. Now, compound events are formed by combining several simple events, and here there are three possibilities. So the probability that either event A or B will occur is the probability of A or B. The probability that both events A and B will occur, which is probability of A and B. And the probability that event A will occur given that event B has already occurred. Now, mutually exclusive events. These are events defined in a way that the occurrence of one event then excludes the occurrence of any other event. So in short, if one happens, the other one cannot happen. So here we have the first example. So there's a group of 200 college students, and there's 140 full-time. There are 80 females and 60 male students, 60 part-time, 40 female and 20 male students. And from this group, one student is to be selected at random. So here's a table. So this is an easier way to break this information down. So again, female, we have 80 full-time, 40 part-time, and 120 total. We have male, which have 60, 20, and 80, and then total, which is 140 full-time, 60 part-time, and 200 total students. So the first thing that we're going to talk about is the probability of A. And the probability of A is the student selected as full-time. P of B, or the probability of B, is the student selected as a part-time male. And then P of C, and this is the student selected as female. So the first thing, and then we're going to talk about which of these two events are mutually exclusive. So as you look at these three possibilities, or these three events, think about which of these two cannot happen at the same time. So the first one is that there's 140 full-time students, 200 total students, so it's 140 over 200, which is 0.7. So the probability of randomly selecting a student, and that student is full-time, is 0.7. How about the student selected as a part-time male? So here we have 20 over 200. So part-time male, there are 20 part-time males, so 20 over 200, and that's going to be 0.1. The next one is the student selected as female. Well, there's 120 female, 200 total, so it's going to be 0.6. So if we think about now, which of these two events are mutually exclusive? Is it P of A and B, or is it P of A and C? Oops, sorry. So looking at these three events, we can see that P of A and B cannot occur because you cannot be a full-time student and a part-time student. However, you can be a part-time student and a female student. So P of A and B are mutually exclusive events. So here's another one. Consider an experiment in which two dice are rolled. The three events are defined as follows. So P of A is the sum of the numbers on two dice is 7. P of B, the sum of the two numbers on two dice is 10. And then P of C, each of the two dice shows the same number. So are these three events mutually exclusive? Well, we have two events, right? So P of A and B. Can P of A and B occur at the same time? So can the sum of numbers be a 7 and a 10 at the same time? Those two events are mutually exclusive. The other one is P of A and P of C. So is P of A and C mutually exclusive? And yes, because if the sum of the numbers is 7, then that means that they both can't be the same number. So that leads us to two rules. The first one is the general addition rule. So let A and B be two events to find the sample space. So P of A or B is equal to P of A plus P of B minus P of A and B. And we talked about this in the earlier lecture when we talked about the queen. Is it a queen? Queen of hearts which a queen and hearts, right? So the queen of hearts, it's both of those together. So that would be the P of A and B. Now in this case, we're looking at P of A or B. Now the next special addition rule is let A and B two events. If A and B are mutually exclusive, then the probability of A and B is 0, so therefore we can just eliminate that from the formula. So here we have the same example that we had previously, right? So P of A, we know it's 7 out of 10. P of B is 1 out of 10. P of C is 3/5. So what is P of A or B? So what is the probability of choosing a student that is full-time or a student that is part-time? Well, in this case here, what we get is 0.8. So 7 out of 10 plus 1 out of 10, and that gives us 8 out of 10. Since they cannot happen at the same time, then that probability of A and B is 0. The next one is probability of A or C. Well, in this case, A is 7 out of 10, C is 3/5. Now, what's the probability of the student is full-time and a female, and they're 80, so 80 out of 200, and that's that probability. And so we add these three fractions, we get 9 over 10, which is 0.9. So the probability of the student being full-time and a female is 0.9. Now, the next thing we're going to talk about is, let me make sure, okay, so the other addition rule. So a single card is drawn at random from an ordinary deck of cards. Find the probability that it's either an ace or a black card. So what we're looking here is the probability of a or black card, and that's going to be the probability of an ace plus the probability of a black card minus the probability of an ace and a black card. So the probability of an ace is 4 out of 52, probability of a black card is 26 out of 52. How many aces are blacks? It's 2, so 2 out of 52. So we do the formula, so the probability of an ace or black card would be 7 out of 13. And here we have the last example. New Year's Eve. The probability of a person driving while intoxicated is 0.32. The probability of a person having a driving accident is 0.09. Probability of a person having a driving accident while intoxicated is 0.06. So what's the probability of a person driving while intoxicated or having a driving accident? So the first one is driving while intoxicated, that's a 0.32. Having an accident, P of A is 0.09. The probability of driving while intoxicated and having an accident is 0.06. So the probability of driving while intoxicated or having an accident ends up being 0.35. So P of DWI plus P of A minus the probability of DWI and A, and that gives us 0.35. And that's the end of Lecture 13, Unit 3. Thank you.